All right, everybody. So now we are in Chapter 8, Section 6. And again, this is Mrs. Masteller. The title of today, it says that we're going to be solving rational equations and inequalities, but we could just scribble that second part out. We're not going to be doing the inequalities part. We're just going to be solving equations, solving rational equations. So as you see in every single equation, there's fractions, there's rational expressions all the way across the board. And these problems are all kind of spaced out pretty far because, well, it's going to take up a lot of room to actually go through and explain how we solve these rational equations. But the definition at the top, it says for a rational equation, the definition is just an equation with one or more rational expressions in it. Get my marker going. Okay, so once again, let me go ahead and define this. It's an equation with one or more rational expressions. And keep in mind that when you're solving an equation, right, you're trying to figure out what the variable is. You're trying to solve it for x or solve it for whatever the variable may be in the equation. Okay, so that's exactly what we're trying to accomplish. We're trying to get to, so like problem number 1, for example, we have some number over the same number, just plus 1 added to it, and somehow this equals 2/3. So we want to know, what is that number x? Okay, the way I view these types of problems, so again, we're going to have typically more than one rational expression in the problem. We're starting off kind of simple and basic for these first few, but what I would probably do, what I always try to do for these to actually solve it, what I'm thinking in the back of my head is I want to get rid of the denominator. If you get rid of the denominator altogether, then you're not even going to have a fraction to deal with, basically. Okay, so I'll explain that as I go through the process for each of these. But starting off, so for number 1, it's just, again, x over x plus 1 equals 2/3. Well, you should recognize that first of all as being a proportion. Proportion, the way I view it, is just really a fraction equal to a fraction. You have a fraction equal to another fraction, right? So how you solve a proportion, easy enough, you just cross multiply. So cross multiplying 3 times x, which is 3x, and that's equal to 2 times x plus 1. So going through and solving, you have 3x equals 2x plus 2 after you distribute. And then solving for x, subtract the 2x on both sides. So you would have 1x equals 2. Okay, so if you plug this back into the problem, it should actually work. So the left-hand side should equal the right-hand side. So if you plug 2 back in, you would have 2 over 2 plus 1, and that should be equal to 2/3, which obviously it is. Okay, 2 over 2 plus 1 is just simply 2/3. So for number 2, the next one, you can't just cross multiply because it's not just a fraction equal to just another fraction. You got that plus 2 hanging on the end. But what you could do to start is move the 2 by subtracting it. Okay, so if I subtract 2, I can subtract a 2 from 10/3, and if I subtract them, that should give me 4/3, and that equals 4 over x. Now, if you'd like to from here, you can cross multiply, but the answer should be kind of obvious. But go ahead if you'd like to cross multiply. You have 4x, and that'd be equal to 12, right? Dividing both sides by 4, and you should get x equals 3. That's your final answer. So again, if you plug this back in, you want to check and make sure it actually works. So we're saying that 10/3 should be equal to 4/3 plus 2. So if I were to add those two together, if you check it, you could use your calculator if you'd like to, but it should be 10/3. Okay, so it all checks out. So for the next one, for number 3, what I'm going to do for this one, to start this off, I do want to kind of stick to the whole cross multiplying thing if I can. So for number 3, I'm going to start by adding 1. I'm going to do that, add 1 to both sides. So now I have x plus 1 equals 6 over x. Because now if I throw that x plus 1 over 1, just make it into a ratio, now I can go ahead and cross multiply. Okay, so cross multiplying, I'd have x times x plus 1, and that equals 6 times 1. So again, x times x plus 1 is equal to 6 times 1 is just 6. Distributing the x, we would have x squared plus x equals 6, and now we should know what to do. We got to set up to factor. So bring the 6 over, you'd have x squared plus x minus 6 equals 0. Factoring, this would be positive 3 and negative 2. And then solving, we get two answers that we got to check, negative 3 and then also positive 2. So plug those back in, make sure they actually work in the end. I'll let you guys know that these both answers do work. So -3 and 2 are two possible solutions. Okay? For numbers 4 and 5, now it gets a little bit tougher. Okay, there's really no way, shape, or form we can go about doing just cross multiplication. So again, what I like to do for these types of problems is I want to eliminate, get rid of my denominator altogether. So we have two of them we got to deal with. We have x minus 1 here and we got x over here. So pick and choose whichever one you want to start with. I usually just kind of go left to right. So that would be the x minus 1. Okay, so now start brainstorming and thinking about, well, how do I get rid of x minus 1? Well, you just multiply. I'm just going to multiply everything through by x minus 1, technically over 1. Okay, so just kind of pay attention as we go across here. Every single term in this equation is getting multiplied by x minus 1. And when I do that, that x minus 1 in the first fraction should cancel. Okay, so as we go across, if I multiply, so on top I would technically have 1 and then x minus 1 over x minus 1, which again, these are just going to cancel. Okay, so now my next term I'm going to have 2 times x minus 1 over x, and this equals 2 times x minus 1. So I'm multiplying again each and every single term, the whole entire equation gets multiplied through by x minus 1. So what we currently have, again, the x minus 1 in the first fraction would cancel, so I would just have a 1 in its place, no more x minus 1, plus, now we have 2x minus 2 here over x, so I'm just distributing, and this is equal to 2x minus 2. Okay, once again, just distributing. Now, I want to get rid of the x, right? The x has to go. So in order to get rid of the x now, I'm just going to go ahead, multiply everything through by x over 1, and that should cancel the x in the second fraction. Okay, so again, every single term you see gets multiplied by x. So if I go all the way across here, I'm doing 1 times x, so that's just x. When I multiply this next one by x, it's just going to cancel my denominator. So I have plus 2x minus 2. And now multiplying 2x minus 2 times x, well, I'm technically multiplying those both, so that'd be 2x squared minus 2x. Okay, and as you see from left to right, there are no denominators, right? I got rid of all the denominators just by multiplying by the denominators, basically. Okay, so from left to right, gotta start cleaning this up now. I would have 3x here minus 2, so just combine those like terms, equals 2x squared minus 2x. Bring everything over to one side, so I'm going to subtract the 3x over here, and then add the 2 while I'm at it. So where I'm currently at, where we're going to have to factor, we have 2x squared minus 5x plus 2 equals 0, and now again setting up to factor. So we should have two answers in the end, and the way that this factors out, well again, 2x squared has to be 2x and 1x, and then multiplying by 2 has to be 1 and 2, so I'll put 1 here, I'll put 2 here, they both have to be negative. So if you just double check for all these two back together, you would have the 2x squared minus 4x minus 1x, and then plus 2. So it looks good. Okay, so again, solving it, I get two answers, x equals 1/2, and then x equals 2. And again, you want to plug these back into the original, make sure it actually works out in the end. But again, I'll just let you guys go ahead and know that these two answers do work. Okay, so always check your solutions. So for the next one, okay, change my color up a little bit too. So for number 5, all right, so again, my objective right now, first thing I'm trying to focus on is I want to get rid of all these denominators, all three of them. Okay, but if you notice the first denominator, it's obviously factorable. So the x squared plus 2x minus 8, and the way this factors, it actually factors into x plus 4 and x minus 2, which are the other two denominators. So truth be told, we only really have two terms we have to get rid of, two binomials, the x plus 4s and also the x minus 2s. Okay, so again, whichever one you want to start with, doesn't really matter in this case. I'm just going to go ahead and start with the x plus 4s. Okay, so I'm going to cancel these x plus 4s in the end, okay, in this first step. So how do I cancel it? I multiply by it, by x plus 4 over 1. So as we carry this all the way across to the first term, it's going to cancel that denominator, and all I have left is 2x minus 1 just over x minus 2 now, because the x plus 4 canceled. And we carry it over to the next term. So this guy, again, cancels the denominator. All I have left is plus 2. Okay, I have just 2 over 1 or just 2. And that's going to be equal to, carried over to this last one, and that would be x plus 4 over x minus 2. So again, taking a step back, take a look at what we got now. It's a lot smaller, right? I got rid of two denominators, two binomials, the x plus 4s. Now let's do the same process. Let's get rid of the x minus 2s by doing the same thing. I'm just going to go through and multiply everything, every single term you see here by x minus 2. So as we carry this all the way across to the first term, cancels the denominator, we just have 2x minus 1. Okay, carry it across now to the next term, so 2 times x minus 2, well that would be 2x minus 4. And this equals, carry it now to the last term, cancels denominator, we just have x plus 4 there. And once again, straight across, as you see, there are no denominators. There's no more fractions to worry about. Okay, so now we just need to go through and solve for x. So on the left-hand side, this would be a 4x, and then that would be negative 5 equals x plus 4. Solving for x, I'll go ahead and subtract the 1x. So 3x minus 5 equals 4. Adding 5 to both sides makes that 9, and then x should come out to be 3. Again, plug it back into the original, make sure it actually works in the end, and I'll let you know that x does equal 3. Okay, that is my one and only true solution. So let's go ahead and continue on to the next page. There's more fun to be had on the next page. Okay, so for number 6, again, our objective, we're just trying to get rid of our denominator, eliminate the denominators altogether. But again, looking at that last one, this is definitely factorable. I'll factor that into the x plus 8 and x plus 2. Again, that's these other two denominators, x plus 8 and x plus 2. So once again, we only have two binomials to really get rid of, x plus 8, x plus 2. So whichever one you want to start with first, I'm just going to go ahead and start with the x plus 2. So I'm going to go ahead and multiply everything through by x plus 2 over 1. All right, so when I multiply the first one, when I distribute, cancels my denominator, I just have 4. Going over to the next one now, so I'm still going to have my denominator of x plus 8, right? But I have to actually multiply on top. But beware, okay, be careful of this part because technically that is a negative 5. So when you multiply negative 5 times x plus 2, I'm going to have minus 5x and then minus 10 on top. Okay, so now carried over to the last one, cancels x plus 2. I have 7 over x plus 8. Okay, now get rid of the x plus 8. So x plus 2's are gone. Let's take care of that x plus 8. So I'm going to multiply everything through by x plus 8 over 1. So going all the way across, starting with the 4, that would be 4x plus 32. To the next one, cancels, and I'd have minus 5x minus 10, just my numerator left. And then carried over to the last one, cancels, I just have 7 over here. Okay, once again, you guys know what to do. Start cleaning this up a little bit. So we have 4x minus 5x, that's negative 1x. And then 32 minus 10, well, that would be 22 equals 7. And now solving for x, subtracting 22 on both sides. Getting x by itself, I'd have negative x equals negative 15. Dividing both sides by negative 1, or multiply both sides by negative 1. But you should get x equals 15. Again, plug it back in, make sure it actually works, but it does. X does equal 15. Okay, moving on to the next one. Let's try this guy. Okay, so factoring your denominators, first of all, x squared minus 1 does factor into x minus 1 and x plus 1. Okay, so pick and choose whichever one you want to start with. I'm just going to start with x plus 1. I want that to go away. So I have x plus 1 over 1, multiplying every single term by x plus 1 over 1. So starting with the first one, cancels my denominator, I just have 5 left in its place. When I multiply the next one, again, it's negative 1 technically. It's a negative 1, it's a minus 1 times x plus 1. So that's going to make this minus x minus 1 over x minus 1. Okay, and this is equal to, going all the way across, it's going to cancel x plus 1. I have negative 2 over x minus 1. All right, now get rid of the x minus 1s. X plus 1s are gone, so last step, multiply everything through by x minus 1 over 1. So going all the way across that first term, that would be 5x minus 5. Going to the next one, cancels. I'm left with my numerator, which is negative x minus 1. Carried over to the last one, cancels, I just have negative 2. Okay, so now just solving for x, again, there's no denominators, they're all gone. But 5x minus x, that'd be a 4x. Negative 5 minus 1, well, that's negative 6, equals negative 2. So now, solving for x, add 6 to both sides. Add the 6. So you have 4x equals 4. Dividing by 4, x equals 1. All right, plug it back in and make sure it works. However, this answer actually does not work out in the end. Let me show you kind of a quick trick. Okay, so again, we got the answer that x equals 1, correct? So if you plug this back in, the key thing, it's not going to work in 2 key spots. It's not going to work for this one, it's not going to work for this one. Reason why, if you plug in 1 for x, just even in those 2 fractions, you would have 1 minus 1 in the denominator. Well, 1 minus 1 is 0, right? We can't have 0 in our denominator. That makes the fraction undefined. Okay, so again, this is kind of the standout spot for me, these right here. If you do 1 squared minus 1, again, that's going to give you 0. So we got an answer, however, it doesn't even work in the end. So technically, there's no solution to this problem. So you always want to check your solutions. Always check them. Okay? So for the next one, I'll go ahead and finish this out here. We have 2 denominators to get rid of, the x and the x plus 3. So I'm just going to go ahead and start this off. I'll multiply everything through by x over 1 to cancel my first denominator, which is just the x. So when I carry it across to the first one, cancels. I'm left with just 20. Plus, carried over to this one. So again, I'm multiplying 5x minus 1 times x. That's going to make that 5x squared minus 1x over x plus 3. And that'd be equal to, carried over to the last one, 7x. Okay. Now I'm going to go through and get rid of the x plus 3. So I'm going to go through and multiply everything through by x plus 3 over 1. So get rid of my second denominator. So going all the way across, 20 times x plus 3 would be 20x plus 60. So the next one cancels my denominator. I'm just left with what's on top, which is plus 5x squared minus x. Turn it over to the last one across the equal sign. So this is going to be equal to, that'd be 7x squared plus 21x. Okay, so now go ahead and start getting everything together. Let's condense. I'm going to start with this side. So 20x minus x. So we have 5x squared. That'd make that 19x plus 60. And this equals 7x squared plus 21x. Okay, again, I like my x squared to be positive, so I'm going to bring everything over to the right-hand side. So starting with the 5x squared, I want that to be a positive x squared instead of a negative, so that'll make that a 2x squared when we subtract it. I'm going to go ahead and subtract 19x, the 21x, and then subtracting 60. So that'll just be minus 60. Okay, so what we currently have, all right, all this stuff cancels out. We will just have a 2x squared. 21x minus 19 makes that 2x minus 60 equals 0. Okay, so now we got to factor this, right? First of all, there's a GCF between all 3 terms. Take out a 2 to make it a little bit easier. And now still factoring the remaining trinomial, 1x squared plus 1x minus 30. So 2 still out front, but this would factor into an x plus 6, it looks like, and x minus 5. So resulting in 2 solutions once again of negative 6, positive 5, but now you want to check them. Again, the key giveaway, really just check in the denominator. You really want to check to make sure that these do not come out undefined. Make sure you don't get 0 in your denominator, which we don't. Okay, if I plug in negative 6, looks okay. If I plug in positive 5, looks okay. So both of these answers should work in the end, negative 6 and also positive 5. Okay, last and final, number 9. For this one, I can just go straight ahead and start cross-multiplying. Again, if you notice, you just have a rational expression equal to another rational expression. You just have a fraction equal to a fraction. I can go ahead and just cross-multiply. Makes life a little bit easier, right? So if I cross-multiply 5x times x minus 2, and then multiplying here, we have x minus 2 times 3x plus 4. Okay, so distributing on the left-hand side, that gives me 5x squared minus 10x. Foiling over here, I'd have 3x squared, and then we'd have 4x minus 6x. So 4 minus 6 would make that negative 2x minus 8. Okay, so now getting everything over to one side. Again, I like to have a positive x squared, so I'm going to subtract the 3x squared over to this side. Go ahead and add the 2x to the negative 10. And then we're also going to add the 8 over to this side. Okay, so all this stuff cancels. That's just all 0. So we'd have 2x squared minus 8x plus 8 equals 0. Okay, so from here, factoring, again, you do have a GCF between all three terms. Take out a 2, so you have x squared minus 4x plus 4 equals 0. Okay, still factoring, 2's out front, so what multiplies before adds to be negative 4, that'd be negative 2 and negative 2. So we really just get one solution in the end. We get x equals 2. So we have the same binomial twice, x minus 2, x minus 2. Again, plug it back in though, make sure it works. But I can see right now this is not going to work. Look at those denominators. If you plug in 2 here, you'd have 2 minus 2 and 2 minus 2 in your denominator. And again, that would give you 0. That's bad. I can't have 0 in my denominator. So from here, although I got my answer, I got x equals 2, it doesn't work. There is no solution to this problem. Okay? So hopefully that makes sense. Not too bad of a lesson overall. Again, if you guys have questions as usual, just let us know. Otherwise, have a great day.